Training a single frontier AI model costs roughly $191 million today. By 2027, that price tag is projected to cross $1 billion per model. Translating that financial cost into physical electricity reveals an even steeper cliff. By 2026, data centers will consume an estimated 1,100 terawatt-hours of power, the energy footprint of the entire country of Japan. The tech industry is currently treating compute like oil. Everyone is frantically drilling, building larger arrays, and burning more power, but nobody has built a refinery. This chart shows the relationship between compute spent and actual capability gained over time. Historically, doubling the compute doubled the power of the model. Today, doubling the compute only yields a 10 to 20% gain. The returns are vanishing. Top industry leaders are openly acknowledging this ceiling. They are signaling the end of the traditional brute force pre-training era. Simply throwing more money and electricity at AI is a dying strategy. It requires a structural architectural shift. So, if the system is breaking under its own weight, why aren't the smartest engineering companies in the world fixing it from the inside? It comes down to a structural trap. The major AI labs are locked in a sprint against each other. If they pause their development cycle to optimize their underlying code, they lose their lead. Then you have the hardware manufacturers. They are selling the shovels. They have zero financial interest in their customers needing less hardware. The major cloud providers are caught in a similar paradox. Because they bill by the GPU hour, improving a client's computational efficiency actively destroys their own revenue. And while academia researches efficiency methods, their end product is a white paper. They don't ship enterprise-grade software. The entire ecosystem is paralyzed by these misaligned incentives. Internal self-correction is impossible. The solution has to come from a neutral third party. You cannot solve this efficiency crisis by building a larger language model or by etching a slightly smaller silicon chip. As you can see in this diagram, Corbenic AI operates in the empty space between the workload and the silicon, creating a missing architectural layer. Their core operational mandate is strict: deliver the exact same mathematical output, but use a fraction of the compute to get there. By owning this execution layer, Corbenic bypasses the industry's incentive trap, providing the optimization that the major players cannot build for themselves. This brings us to their first infrastructure primitive, Merlin. Its job is mechanically straightforward: automatically find and remove work that a machine has already done. In AI training, duplicate data wastes 10% of compute. Merlin acts as an intelligent sieve to filter out redundant packets before they reach the processor. This exact logic applies directly to stripping duplicate cybersecurity logs or cleaning up redundant aviation radar pings. Merlin acts as an automated auditor for the tech industry, eradicating redundant processing cycles before they ever burn through expensive time and energy. Their second primitive, Taliesin, tackles a different kind of waste: the extreme vulnerability of running complex, multi-week computations. Imagine running a massive scientific simulation for an entire month. If the system crashes in the final hour, historically, that data is lost. You have to start over from scratch. Taliesin prevents this by allowing these massive computations to perfectly save their state of progress. If a machine goes down, the workload seamlessly restarts on a different server without losing any progress. But the critical differentiator is mathematical certainty. Taliesin proves that the final output from an interrupted run is identical to what a perfect, uninterrupted run would have produced. It functions as an infallible safety net, removing the risk of catastrophic loss for the world's most expensive calculations. The industry has hit a physical limit. You cannot conjure a new electrical grid overnight to support an infinite expansion of data centers. Because of this, enterprise buyer behavior is shifting. The primary question is no longer how big is this model, it is now how cheap is it to run. Increasing regulatory scrutiny is transforming computational efficiency from a cost-saving bonus into a strict compliance mandate. Corbenic AI provides the essential infrastructure to bridge the gap between our physical hardware limits and our software ambitions. Brute force drilling has created the AI boom, but ruthless mathematical refining is the only way this industry moves forward.